Hello guys, good morning. Hope you all can hear me. So let us start the session. So this okay, it was not saved. Oh yeah, it is saved. Okay, that's fine. Let us rerun this one. Perfect. So this is what we have seen yesterday, right? Until this one, we had able to sort the data using the sort function. As you can also use order by. Both are same. Instead of order by, you can also use sort. Both work similar way. Okay, so that's perfect. Now, so the requirement can be like this. The requirement can be like this, and the user don't wanted to see the data. Who are? Okay, let me see df6 dot show if this is working or not. Let me see. Yeah, perfect. So I wanted to filter it out the data. The client wanted to filter the data where employee tax is less than 500. He don't wanted to see those people. Okay. So for that scenario, filter or where we can able to use to filter the data. Right. So in SQL also we have a where condition where as per the logic is like employee tax is more than 400 only the client wanted to see the data. Less than that, he don't wanted to see it. So for that one, in SQL, what we are doing in SQL, we will be mentioning like select a star from the table where the employee tax is more than 500, right? So that's what we do. And here also we will be doing the same thing. What we will do is that, for example, I wanted to create a df7 is equal to df6 dot filter. You can use or where you can use both are working in the same way where df6 dot employee tax. This column is coming from where, sir? This employee tax is coming from the df6 data frame. Okay, employee 6 more than 500, more than 500 or more than or is equal to 500, right? So this is what it is. And if you wanted to see df7 dot show, okay, see here, one of the record was 360 rupees only. So that's the reason that record was removed. Only we have filtered it out. Only four records are there where the employee tax is more than 500. That means, see, we can able to filter out the data using the filter option as well. Using the filter option as well. So this is a one more criteria. Either you can use filter or you can use where also. I am going to tell you how you can use the where. So df6 dot filter. Sorry, instead of filter, we are going to use where, right? Where df6 dot employee tax more than or is equal to 500. Okay, so you can actually use anything, both are same. Either you can use this one or you can use this one. Okay, you can run it. See, the same thing. The number of records are same. Okay, so you can use anything, guys. Both are same. So this is how you can able to filter it out the data. Okay, and sometimes if you wanted to filter out the data, there are sometimes like multiple conditions will also be there. This is a single condition. The single condition is this one. There will be a multiple conditions also, and the multiple conditions are like, sometimes he wanted to see the employee country is equal to India only. So how do we incorporate that, sir? So if you wanted to mention that here only, if it is a like SQL, we have a and or. Here also we have a and or. If you wanted to achieve it, you can also achieve the same thing. So for example, the same scenario I am taking it here, and I will be mentioning and one more condition. The one more condition is employee country. df6 dot employee country is equal to India. Okay. So this is a one more condition that I am putting it. I'm gonna remove this one. Okay. Now see it here. So df7. Okay, bracket is not closed. Okay. Yes. See here, we have all the records because all are employee countries, all people employees countries in India only. So that is the reason you have got all the employees tax is more than 500. Employee country is India. So you can able to see it here. So this is how you can able to apply multiple conditions as well. Okay, you can mention R. If you wanted to mention R, you can also mention this one, pipe symbol. If you can mention the pipe symbol, see, all the five records comes, guys. Why? Either this condition or this condition. If the first condition, we have only four records. For the second condition, all five records, all five employees are coming from the India only. So that is the reason all the things will come into the picture. Either you can use and or you can use or. Okay. So I'm going to copy this thing. I'm going to paste it here for your exam, for your understanding. I'm not running this command. Okay. So this is it. Either you can use and or. Sir, if you have one more condition, what you have to do? You can mention if it is and, you can mention it here, or if it is or, you can mention it here. So that is how you can able to come up with a logic. You will putting that logic in the where condition. Inside the where function, you are going to do it. Okay. So this is about the where, sir. Okay, and after that sometimes, sir, this where is fine. Now I have got the df7, that's actually perfectly fine, but the user wanted to see those people whose name is starting with the s, whose name is starting with S, or whose name is ending with A. So such a kind of a requirement is there for the user, for the client. He wanted to see only the names starting with S. Now what we are doing in the SQL, sir, for this kind of a scenario, whose name start with the S or whose name end with some A, whose name is having some TH or something like that. So double E. Okay, when you have such kind of a requirement, how do we solve it, sir, in SQL? Anyone? No one? Are you guys able to hear me? Right. So we will be having like operator in SQL. We will be using it to get in where condition. We will be mentioning the like operator to achieve this kind of a things, right? Starting with A, ending with this one, having this thing. So such kind of a things we can able to easily achieve it with the help of the like operator. I hope you guys can hear me. Oh, yeah. Some people are already answering it, I guess. Yes, you can't hear me? Hello?
I can hear you, sir. Ram this side.
Okay. Okay, let me know, guys. If you can able to hear me, that's fine. If you are not able to, let me know. Okay. Yeah. For example, the thing is this one. He wanted to see whose name starting with S, A, S or A or something like that. Whose name start with S. Okay. For example. So what we are going to do, we are going to create a df8 that is coming from the df7 dot where 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 employee name, right? df7 dot emp name, employee name starts with the A, start with S, right? So dot like inside the like what we will be mentioning, sir, it is starting with S. That means inside the brackets, starting with S, ending with anything, that means percentile. Ending with anything. So that means percentile. You can mention here dot show. Okay, so this sorry, show is not required. So df7 dot employee name like starting with the S. Okay, this is where you are going to get it. Now df8 dot show. So you can see here, I have got only two records because whose name starting with S, so I have got only two records. Okay, this is how. If you have a one more condition, feel free to mention it here. For example, I have and is also there. I wanted to mention one more condition also. So this is the final and this I wanted to put it in some bracket and this is also in one more bracket. Yes, whose name starts with yes, and if you want to mention whose country is also whose employee country is India. Okay, df7 that employee country is equal to India. So you can also mention multiple conditions. Okay, or like operator only. For example, like operator only. If you wanted to use something like this, something like whose employee name ending with A. Now tell me, guys, what is the whose name is ending with A? What is the logic for that? Whose name is ending with A? Sir, whose name is ending with A? Anyone? What is the logic I have to mention it here? No one? You guys already know SQL, right? Whose name is ending with A, sir? Percentage A, yeah, percentage A. Yeah. Okay, so this is very simple. So whose name ending with A? Now, if you run it, you see, oh, you have only one record, that is whose name start with S and whose name ending with A. Okay, and some situations there will be a requirement also like this. It's not with this one or it's not this one. Sometimes the requirement will be like this. What is that, sir? So he wanted to see those people whose name is having double E. Now the requirement is having whose name is having double E, E and E, E, E after E. Okay. So for that one, what is the logic? Right. So you can see what was that? Something wrong somewhere? Oh, okay, bracket closed. Okay, see here, Sandeep, double E is there. So that is how you can able to use the like operator, where you can able to easily. Some people are mentioning in the chat. That's actually very good, guys. So whenever I'm asking something, right, you will be able to recall it. You have to tell it because that's what happens in the companies also. You should be able to recall. Okay, now tell me. So this is how we have achieved with the help of the like operator, employee name starting with S or ending with anything or which is having double E, whatever the thing we can able to achieve it easily. Right? So this is a one more example that we have seen. Okay. Sorry guys, something wrong. I'm just looking at this one. It's not running yet. So 1 minute, give me 1 minute. So let's try to fix it out. Let me close it, save it, close it, close it. Let me open it. Okay, let me run it. Yeah. Great, it's running. Okay, so now you have. So I just don't wanted to mention this logic. Okay, so I just wanted to mention starting with the yes, starting with yes, ending with anything. Okay, at least we will be having two records. Okay, we have two records. Now this is how we do it. And if I print the schema, df8 dot print schema, if you print the schema, what is the problem, sir? Everything is good, but you see here the employee tax is double. So sometimes you will be providing schema properly, structure type and structure field you will be using, and you will be providing the schema properly. But in between you are adding some few columns, and for that you wanted to change the data type. So if you wanted to change the data type, and how do you do that, sir? Okay, for example, sir, I wanted to write some kind of a situation here. What is that is, for example, I wanted to write some kind of a where condition. df9 is equals to df8 dot filter, filter it to filter out the data, where df8 dot employee tax is equal to 500. If I give it, if I give it some 540, if I give it, I wanted to get the data. Okay, if I give it, I wanted to get the data. df9 dot show. So we have got it. That's perfectly fine. And if I give, so because it's a double, so that's the reason it is working. Sometimes what will happen is that this employee tax may come as a string. Okay, employee tax may come as a string. In such scenarios, how do you do that? If you wanted to convert the data type, what do you do that, sir, in SQL to convert the data type? So to convert the data type, you can actually use the cast function, right? So in such scenarios, you will be using the cast function. Okay, so for example, while you are writing this logic, you will be mentioning dot cast as integer. Okay, you can actually mention like this, and you can run your query. Okay, you can run your query. So if it was a string, right? If it was a string, we are in converting it into the integer or float, then we will be running the aggregations. Okay, so this is how you can use the cast function to cast the data type. To convert the data type, you can actually use this one. Okay, so this way you can able to do it. Now you see here we have converted this one, or sometimes instead of this one, what I will do, here it is came as a double, right? I don't want it to be a double, I wanted it to be an integer. So for that one, what I am doing it, you see here df9 is equal to df8 dot select. I'm selecting all the columns. Okay, I'm going to select all the columns. Okay. Okay, let's see. Now here df this one is there, right? So for example, employee tax. So usually if I wanted to do some kind of aggregation, what I will do, df8 dot employee tax. Usually this is actually good. And dot cast, I would say integer. So this is how I will be doing it. Okay, sorry. I wanted to see the data, right? So df9 dot print schema. Now if you see it, see here, it become integer. So that's how, if you wanted to in between, if you wanted to change the data type, you can actually use the cast function to convert the data type. See here, employee tax earlier it was double. Now I converted it into the integer. Okay. So if you wanted to look at the data also, df9 dot show, and you can look at the data as well. See here, earlier we have a dot zero, we removed that. So float double or float will be having decimals, but for the integers it will not be having any decimals. So that's the reason you see here you don't see any decimals here. So that's the thing about the cast. So if you wanted to convert the data type, you can able to do it with the help of this cast. Okay, yeah. So we have lent cast, we have lent this one. So sometimes if you wanted to alias the column also, I told you alias the column, how to alias the column. For example, if it is not just employee tax, it is total tax. So for example, in that case, you can actually use alias you can mention and mention it is total tax. It is not just employee tax. The column name should be total tax. Okay, so you can actually do this thing. Okay, the column name become total tax now. Alias to alias your column. It provides the alias to that particular column. That's it. Okay, so this is what it is. So here what we have learned, two things. One is cast function to convert the data type. One more is alias provides alias to the column. Okay, so these are the two things that we have learned here. Okay, and after that, so we have already learned the filter, all of those things, multiple conditions also we have seen, and yes, so sometimes the data may be like this. Okay, sometimes what I will do, did I tell you the drop duplicates? No, right? So yeah, I'm gonna take this one, copy. I'm gonna take this one, I'm gonna paste it here. Okay, if you don't want it to see the data like this, you can actually look at like this. Okay, this is good way of looking at the data. Now, give me 1 minute. I'm gonna come up with a good data. So I'm adding some 100 records. I don't want it to add it here. So I'm gonna go to the top and I'll be adding it here only. It's fine. See here, this 11 record, Lucy, you will be having Lucy somewhere already. Look at guys. Sandeep also somewhere. Lucy also somewhere. Sandeep is here. So Sandeep record is duplicated. And Lucy's record also somewhere it will be. Look at it here. So I don't see Lucy. So that's fine. And Susan. Yeah, Susan is here. And Lakshmi. Lakshmi is here. Natalia. Maybe. Okay. Some records may be having duplicates. Some records may not be having duplicates. That's perfectly fine. So if I run this entire book, what will happen? You see here. I'm going to run this entire book because I just wanted to take it out. So that is what happens, right? Tomorrow you may be getting some new data. Your code has to run. So for that purpose, restart the kernel. Okay, one by one, entire code will run. Okay, see here. First, we will be having 20 records. Okay, this is the data type, and we have also fixed this thing. You can see here. This one, what we call the schema, also properly fixed. After that, we have added a column called like India employee tax perfect and country converted into employee country perfect. And this is also we have changed this. See, it was earlier we have this much heavy data. Now we removed it with just a single letter perfect. And after that, sort and order by is also done based on the names. So order by sort was coming at a, I mean, um, it was alphabetical order only, but a descending order. And after that, filter it out. So we have filtered the data, and like starting with yes, and you can see here we have also done this one total tax alias the column, also converted the cast data type. Okay, that's perfectly fine. And what is the problem with this data? Can you guys tell me what is the problem with this data now? Look at the data and tell me what is the problem. Correct. So there is a duplicates. So right. So we need to remove the duplicates, right? So we have a drop duplicates function to remove the duplicates. To remove the duplicates. How do we do use that, sir? So now until df9, now df10 is we are going to use it to remove the duplicates. That is df9 dot drop duplicates is one of the function is there already. So you can use drop duplicates, and you can mention which column you wanted to remove the duplicates. If you have a column, like where do you, how do you want it to remove the duplicates? So if you have a employee name and employee gender like that, right? So for example, employee name is repetitive, then you wanted to remove the duplicates. In that case, you can mention employee name. Okay. So if the employee name is having some kind of a duplicate, you are going to remove it. df10 dot show. Sorry, the employee name is unable to understand it, or it is our issue with the df9 dot employee name. I will mention it like this. Drop duplicates df9 dot employee name. Employee name is correct. Drop duplicates df9 dot employee name, and what is the error? If I wanted to remove the duplicates on a specific column, I have mentioned that specific column here, and I'm mentioning it here. I don't understand the error here. Column is not iterable. Okay, that's fine. I have mentioned here like this. I don't understand this one. Some typo. Let me see. Column is not iterable. What does that mean? If it is unable to do it, I may have to use it in a different way. So I'm gonna do it like this in a bracket so that it will not be iterable. Okay, it's the same. Or I can do it like this. Yeah, it's running. See here. So drop duplicates I have used is if the column name is not iterable, sometimes what will happen is that you may have to use that in the square brackets. So in such scenarios, you can use it like this. See here. Now earlier we have this Susan duplicated, Sandeep duplicated, and now we have only 3 records. Okay, so this way you can able to drop the duplicates, but this kind of a thing you have to do it very early stages. This is not a good way of doing it. Okay, So usually if you wanted to remove the null values or duplicate values, you have to do it first. So that's where the performance will be highly increased. Otherwise, if you are doing all of these aggregations and transformations and doing the drop duplicates at the latter, it will not actually increase the performance. It rather reduce the performance. Okay, so that is the reason always use such kind of a filtering or this kind of a duplicating null values. All of those things do it the first time. So that is what it is. So you can mention it like this. Okay, and this is also one more thing. And you can mention any specific column names, sir. Okay, sir, I wanted to mention one more column name also. If you wanted to mention one more column name, you can mention it like, sir, for example, employee general also I wanted to mention. You can also mention like this. Okay, so employee general. So for now, the combination of employee name and employee general are the one wherever it is repeated. Susan plus F, wherever it is two times repeated, right? So that's where the duplicates will be removed. So for such scenarios, you can actually use this thing. Okay, yeah. So based on some country column or salary column or however you wanted to use it, employee ID or however you wanted to use it, you can use it. Okay, so this is how you can actually use this. Drop duplicates to remove the duplicates. Okay, so this is also one more thing. And the next thing I wanted to talk about is, yes, so this is the one. So for example, assume that you have a data, assume that you have a some January data, you have then February data, you have then March data. Okay, the user don't wanted to see this as a these are, you can think of like some CSV files. Okay, this is one CSV file, second and third, and the user don't wanted to see them in a different files, and he wanted to see them in a table. First thing, he wanted to see them in a table, and it is in a single table only, not in three different tables. For that one, how do we do that, sir? Okay, for that one, how do we do that? How do we do that, sir? Anyone? The user don't wanted to see three, so you have like this. So here one comma Ravi is there, two comma Lakshman is there, and here 3 comma Ram is there, here 4 comma Swami is there. So he wanted to see all of this data in single table itself. Okay, so he don't wanted to read the data from these things, and he wanted to create a different table. Okay, if you wanted to create a different table, all the data will be in different table. He don't wanted to see it, he wanted to see the entire data in one single table. So how do we do that in SQL? Join will work here. Do you think the join will work? Sorry. Yes, union. Perfect. So we are going to achieve it with the help of the union. That's actually correct. Okay. So let us try to do that. So union to match the data. Right. So let us see. For example, okay, let me take data one. Okay, this is my data one, sir. Okay, one ls Bob Charlie. And likewise data two. This is my data 2. Likewise, I have a data 3 as well. Likewise, I have a data 3 as well. Okay. So for all of these things, so if you wanted to apply the union, can anyone tell me what are the conditions? If you wanted to apply the union, what are the conditions usually we have to follow, sir? We have to know that the number of columns should be same. Yes, number of columns same, and the data type schema should also be same. Schema should be same. Should be same. Otherwise, we cannot be apply the union. Okay. If this particular data is having 3 columns, if it is having 2 columns, you can't apply it. Okay. If the data type is also different, you can't apply it. Okay. So for the reason, whenever I am reading the data 1, I will be creating my own schema. The schema 1 is this one. Okay. Structure type, structure field, employee ID, employee name. Integer type, integer type. True. True is nullable. I mean, you will be having such kind of a thing is right. So whether the data should be null or true, so that's what the records are there. So for the same scenario, I will also be using the data 2, the same schema, data 3, also same schema. Okay, you can mention here schema 2. Okay, or you can mention here schema 3. Okay, so this is how you have the schema readily available. Okay, now you have to create the data frame for each of these things. First data frame for this one, second data frame for this one, third data frame for this one. So I'm going to create it like this. So this is the sample data that you have. Tomorrow you may be having this data coming from CSV file. You already know how to read the data from CSV file. Okay, you know how to apply the schema 1. And after that, what you will do, sir? You will be creating a data frame 1. And after that, you will be creating a data frame 2. And after that, you will be creating a data frame 3. Okay, this is how you will be creating data frame 1, data frame 2, data frame 3. After you creating the data frame, we don't want it to see the data in 2 different tables. We wanted to do it. So that's the reason union underscore data frame is equal to, you wanted to have, okay, merge the data frame. I would say merge the data frame is equal to df1. I wanted to merge it with the df2. I wanted to merge it with the df2. And this data has to be merged with the df3. Okay, so this is how I am going to do it, sir. This is how I am going to do it. And copy it, dot show to see the data. And dot print schema to print this. Look at here, sir. Earlier, this data is individual data. Now I have merged the data and I have printed the schema also. You can see it here. The schema should be same for all employee ID, employee name, integer string, integer string, integer string, same names. If the name is different, if the number of columns is different, data type is different, it will not work. Okay. So first what we have done, we have created 3 data frames, df1, df2, df3 with hard-coded data. We use the union method to combine them and on top of one on the other, and then we can able to result it out. Okay, is this clear, guys? Great. And final, I wanted to give one more idea today related to the aggregations. Okay, so related to the aggregation. So for example, I'm going to take some sample data. Give me 1 minute. I'm going to get some sample data. One minute, sir. Somewhere I'll be having it, writing it, and I think is a bit hard. Yes. Now I have some employee data. I'll just say data. Okay, the employee data. So you can see here. Okay, he did not give one. Okay, so assume that I have that employee data like this. Look, what? Okay, okay, you can see here, guys. I have the employee data like this. So data is equal to 1 to 20 records are there, names and salaries, department, gender. Okay, I wanted to define the schema for this one. I'm going to define the schema. The schema is this one. Okay, the schema is this one. Okay, you can see here the schema is this one. I have defined the schema with using the structure type and structure field. You see here ID, name, salary, department, gender, and integer type, string is string. Okay, so this is perfect. Now I wanted to create a data frame. Okay, I wanted to create a data frame. The data frame is like this. So data frame one. I'm going to use data frame one. Okay, is equal to, you already know this one, right? Spark dot create a data frame, data comma schema. And if you wanted to show the data, you can able to show it. Okay, this is perfect. Now the question is, I wanted to get the employee count in each department. Sir, I wanted to get employee count in each department. Now tell me, sir, how to do that in SQL? Sir, how to do that in SQL, sir? Group by, yes. So for that one, we are going to use the group by, comma, and we are going to get the count. For that one, what are the things that we have to remember? Which one we have to use it to get the count? We need to use the aggregate function, right? Otherwise, we don't get it. So with the help of the group by and aggregate functions, we are going to achieve this thing. Okay, I'm going to mention it here only. With the help of group by and aggregate functions, we are going to achieve it. So get the employee count in each department. For that one, sir, df2 is equals to df1 dot group by, and which column we have to group by, sir? And which column we have to group by, sir? Right, department. Yeah, and the syntax for the count is, you can actually use directly, you can use count, that's perfectly fine, but it's not a good way of using it like that. So count, minimum, maximum, all of those things are comes under aggregate functions. You can actually import those things. Aggregate I will mention, and you can mention count. Okay, count of employees means I will mention this ID. Okay, ID. So that is how you can mention like this. Okay, so now you have this one df2 dot show. Okay, now you see here something wrong. Okay, count is not defined. You usually, these functions are not defined directly, so you have to import it from pyspark dot sql dot functions import count. If you have min tomorrow use, max tomorrow use, um, average, sum. Okay, better to use all of those things here. See here, In the sales department, I have, so see here, I have 7 employees, HR department 6, IT department 7. But this is not good. This naming is not good. I wanted to rename the column. Now tell me, sir, how I can do that? Correct. That alias. Perfect. You guys are following it. So count of employees. Right? So count of employees, this one. Okay, this is fine. The user wanted to see the maximum salary in each department also. Okay, he wanted to see the maximum salary in each department also. So for that one, I wanted to add one more column here. So for that one, what I will do, comma, I will mention here slash. I will use dot aggregation and the maximum salary, right? Max of column name is salary, and I would alias it alias max salary, max salary. I think this is perfect. Okay, dot aggregation. I think dot aggregation is not required. Okay, this is actually the same function. So max, this is count, this is max comma I have used, and this is not required, and this is perfect. Yes, I mean you can look at here, you can able to get it easily. Okay, in the aggregate function itself, I have brought count max. If tomorrow it is minimum, you can actually add minimum also. See here, maximum salary in this department is 6,300. This is how, this is how. Okay, yeah. If you wanted to mention minimum also, you can do it. Okay, so if you wanted to mention minimum also, comma, minimum of, I'll just copy this entire thing. Minimum of salary, right? Minimum of salary, that is I'm called as a minimum salary. Minimum salary. And if you wanted to mention average salary, average of salary. Or if you wanted to mention sum of salary, sum of salary. The comma you can remove, and perfect. Right? You see here. So in each department, I've got maximum salary, minimum salary, average salary, sum of salary. This is what the people will usually be asking in the questions, guys. Okay, so you can able to tell them this is the maximum salary, this is the minimum salary, this is how we are going to get it. Okay, yeah. Any questions on this one? Okay, yeah. Tomorrow we are going to learn about. I'm stopping here for today. Two things are left. One is ranking functions, comma joins. Both of those things we are going to complete it tomorrow, and I will tell you one example so that you can able to achieve it. Okay, yeah. This is what it is that we are going to see tomorrow. Any questions anyone having on this thing today? Rounding for what? Sorry. Correct. You can apply those things. You can apply those things. For example, so to apply that, there will be some kind of a function is also there. I don't want it to see this entire thing. So, for example, this average salary, I have this many decimals coming. By default, if you wanted to mention only few decimals, I think you can apply it. So, let me check. Give me a minute. I think you can do that. There will be some kind of a function. I actually might have forgot it. So you can actually mention round kind of a thing. But let me check in the PySpark. We have a round. I think round is the only thing. So yeah, it is there. Yes, we can use it. Okay, how do we use it? Perfect. A comma 0. Okay, we can use it. So you can actually come here, round, and this is your salary, comma. If you want one decimal, you can one close it. I think this is good. Brackets also perfect, right? Yes. The round is not defined. We may have to import that round also. So yeah, it's also a function. You can actually mention it here, comma round. It's also a function only. Yeah, you can see here. Yeah, that you can do. Okay. If you want two or if you want three, you can just change it. Yeah. Any other questions, guys? Yeah. You can use most of the times people are using the data frames only. Okay. So in PySpark, you have a data RDDs also there, but people are using the data frames only because compared to the RDDs, data frames are the ones which is having performance upgrades, and the optimization is very easy. And one more thing is that RDDs does not provide the schema properly, so we can actually provide the schema also. So there are few differences. So that is the reason most of the people are working with the data frames only. Yeah, and it is Spark can be used for anything. Spark can be used for structured data and semi-structured data also. Yeah. Okay. Any other questions, guys? Okay. If this is it, we will be stopping here for the session. I'm gonna save this page and I'm gonna stop it here. Maybe once tomorrow I will be sharing you this transformation also. Tomorrow we will be completing this transformations. I will share it with you guys. This one. Okay. Yeah. Any other questions? Okay. Thank you all. Have a great day.